Reverberation, a physics principle, starring Team Sloth. Brandon Green Thompson, Recording Arts Bachelor's Degree Program, November 2012.
Raymond Gonzalez, Recording Arts Bachelor's Degree, November 12.
Jordan DeBow, Recording Arts, January 2013.
Yo, this Dre Adams, Recording Arts, March 2013. Mr. Order Crab Legs with the heavy butter. Know what I'm saying? I directed this whole piece. I hope y'all like my physics principle. Team Soft all day. Woo woo!
By the way, I'm Joseph D'Elia.
Reverberation is the continuation of a sound traveling through a space after the original sound is produced. Reverb occurs when the sound is produced in a room, causing echoes to build and slowly disappears as it hits the air and walls in the room. We chose to use different sized rooms for our project. Some of the variables were the difference between carpet and tile, the soundproof walls, and some of the items that filled up the room like chairs and tables. Based on these variables, as a group we thought that the room with the soundproof padding would show less signs of reverb, and we were right. The first room that we tested gave us a lot of reverberation because it was an empty hallway. The sound of the slap bounced off of all of the walls and created an echo. In the second test room, most of the echoes that the slap created were eliminated by the padded walls.
Using machine to generate short, loud samples, a small set of speakers to introduce the samples into the different environments, and a microphone to capture the acoustic anatomy of each environment, we will demonstrate that reverberation is more prevalent in environments comprised of less absorptive and more reflective surfaces. In order to truly capture the impulse response of any room, you need the shortest, loudest sample you can find.
Hi, we are in the Roots and Recording hallway doing our minor reverb test. Over here we've got our microphone. It's going to catch our sound. Got our speakers playing our 808 clap through the machine, and Joey's over here messing with the logic. You ready to get started?
Yes.
Okay.
Placing the microphone in the middle of the hallway gives us the ability to capture the environment's acoustic anatomy. If you listen again, you can almost hear the floor, the walls, and all the other real flat surfaces in the hallway. What you're actually hearing is thousands of reflections off of the walls, the ceiling, and the floor that all come back together to make reverberation.
This is test 2, non-reverberant room. You can see here we have absorptive materials on the walls, ceiling, and there's carpet on the floor. You can hear in my voice, as opposed to test 1, that there's not very much reverb or echo in here, and we're going to get started.
You can hear a clear difference in the way that the sound travels in the two different environments. Think back to the first environment where you could almost hear the feedback because the microphone was picking up all of the reflections. As opposed to the room.
In conclusion, we discovered that the reverberation is greatly affected by the dynamics of its environment. The reverberation can be greatly magnified or reduced depending on the types of surfaces present. Therefore, reverberation can be removed or utilized by the professionals in our industry. It is very important in the recording arts industry to understand the process, problems, and opportunities presented by reverberation.